We're very fortunate to have Ned Roselle with us this afternoon. Ned has written weekly newspaper columns about science since 1994, more than 500 of them. He has traveled with scientists from Attu, at the tip of the Aleutians, to Akuk Bay in Juneau. Last week he completed a 900-mile snow machine journey with Dr. Kenji Yoshikawa, sleeping in every BSSD school except Diomede. And with the wireless internet in all the schools, posting entries on his blog at alaskatracks.com. With this lecture, Ned will take us on a trip around Alaska with scientists in action. I'll pass it off to you, Ned.
Thank you, Glenda. As Glenda said, I'm Ned Roselle. I live here in Fairbanks, and I've been a science writer here since 1994. And in that time, I've traveled with a lot of scientists who've done a lot of different things all over Alaska. I like to see new places in Alaska, and it seems like scientists go all the really interesting places that are really hard to get to otherwise. And when I've been with them, they've gathered a lot of information that they've done a lot of good stuff with. So I'm just going to take you guys on a trip throughout Alaska to some of the places these scientists have worked, and I've tagged along with them. So here we go. Scientists scrambling over Alaska. Like I said, scientists get to some of the neatest places in the state. A lot of them work here in Fairbanks too. There's an awful lot of scientists here at UAF, so for a science writer, it's a really good place to work because I can accompany scientists and not even stay overnight anywhere, though I love doing that too. Here's a shot of a recent big fire year we had in Alaska. This is Fairbanks in 2004, when the whole month of August was basically all choked with smoke like this. People didn't like it too much, but it was a good opportunity for some scientists to sort of check out our air quality and see, gosh, how much smoke can the air hold, and how is it affecting people. This is Kathy Cahill. She works here at UAF. She's an atmospheric scientist, and she is here sampling the air at Valerie Therrien's house in downtown Fairbanks. Valerie tried to seal off her house to try to keep the smoke out and the clean air in, and Kathy was trying to see how successful she was at keeping the smoke out. A lot of people just have to work outside no matter what, so they were working outside in the smoke. These guys were working on analyzing a stream north of Fairbanks in one of the many creeks named Cripple Creek in Alaska, and they were looking at all sorts of different qualities of this stream. Even they turned over a lot of rocks here to look for sort of little creatures living under them, a lot of insects in the stream, a lot of life there you wouldn't think was there. And that's Fairbanks when it's a bit less smoky and more pretty in the summer. We're looking forward to that coming up soon. This is just north of Fairbanks, Poker Flat. Scientist in the background is named Martin Jeffries, and he has a network of lake ice monitoring stations out there. Might be one in your village or town. And this is out north of Fairbanks at Poker Flat Research Range at a lake out there that he monitors every spring. This is a scientist who looks at willows on the flats of the Tanana River downstream from Fairbanks. He studies willows and how moose interact with the willows and sort of engineer the landscape out there. Here's another Fairbanks scientist who works on trees. This is Diane Wagner, and she works here at UAF also, and she studies aspens. And Fairbanks and the interior, most of Alaska, and a lot of the Yukon in the past few years has been hit hard by this guy, the aspen leaf miner, which turns the leaves from green to sort of metallic looking, silvery. they've been studying them the last couple of years to see how they're affecting the aspens. Another place that scientists study here in the interior is the Denali Fault. I like this picture because it shows sort of this frown across the middle of Alaska, and it's just a gap where this strike-slip fault has been striking and slipping for thousands of years, and that slight motion has kept this gap sort of clear of mountains. There's a lot of glaciers in this gap that shattered on November 3rd, 2002, when the Denali Fault earthquake struck. It was a big earthquake, magnitude 7.9, and when it hit, it sort of ripped through almost 200 miles of Alaska, ripping up glaciers and tundra, and it was a really big event. And scientists thought it was a really good opportunity, so they were all over it right after it happened. On the east end of the fault here, where things were really shattered on glaciers and stuff, and also on the west end, which is where this picture is from. This is sort of by Cantwell, and by Cantwell, over on the east end, the surface of the ground didn't rip, it stayed intact, and scientists wonder why it did. And here they are, right on the fault line. These scientists dug a trench just with hand tools, shovels, and picks, and they wanted to see what the Denali Fault looks like where it hasn't ripped. And they could read the side of this trench and see when the last time there was an earthquake there, because they're really curious about when this is going to go again. And we helicoptered in there, camped out. It was in August, really pretty, and that was the view at night from there. Really nice spot. That's another advantage of going out with these scientists. You get a lot of good camping, a lot of nice sunsets. Another place scientists go is to the top of Denali. That's a picture of Denali. The highest mound there you can see is Denali, 20,320 feet. And every year, scientists with the International Arctic Research Center go up there. They've had a weather station up there since 1999. The Japan Alpine Club put this station way up there at 19,000 feet, about 1,000 feet from the summit, just above Denali Pass. This weather station had stood from 1999 until 2007. And when these guys went up last year, they found this stand, which is a tetrapod. It's like four-legged stand. They found it blown over in a big wind. And last year they didn't have the tools to fix it when they went up, so they just secured it to the mountainside, and it's unsure what they're going to do with the project now. The problem with this station is it's in Denali Pass, which is sort of this notch in the mountain 19,000 feet up, and the jet stream sometimes dips down there in midwinter, and just some incredible winds go through there. Like, they measured a wind speed of 150 miles an hour before the station last broke. So there's probably 200 mile an hour winds going there, which is why it's such a hard place to have a weather station. It's pretty hard to work on too, because you get up there and you're pretty dumb from lack of oxygen. But these guys have done it for about 8 years running. Take you out to the Seward Peninsula near Nome, where this guy was out there once collecting lichen for a reindeer scientist, because he wanted to check out what sort of habitat this was going to be for reindeer. But I hiked with him for about 4 days, and this was the best view we had. But we did get a lot of lichen, and that was our mission, so mission accomplished. A couple years ago, some scientists transplanted some birds from this island way out in the western Aleutians, Agatu, which is this island here. It's a beautiful island way out there. No people live there. This cabin that you can see in this picture was built by Russians. There's a Russian grave there. Right in that deep green there by the cabin, those are all what they call midden sites, where people lived a long, long time ago. You'd find like stone points there, human jaw bones, a lot of animal bones. Anyway, these biologists for the National U.S. Fish and Wildlife Service, they were there because there used to be foxes on the island. The Russians introduced foxes to this island, Arctic foxes that had valuable pelts. But the foxes would, once they were introduced on the islands, they did really well. So well that they killed a lot of ground nesting birds out there. So the Fish and Wildlife Service, starting in the 50s, wanted to get rid of all the foxes. And foxes are pretty easy to trap out on these islands. They were the kings, no bigger predators than them. So Fish and Wildlife Service was pretty good at trapping them. All they'd have to do was set out some like old traps, bait, and they would get most of the foxes. And Agatu, this island, they caught the last fox in 1999. So it's a fox-free island, and since it's fox-free, they wanted to reintroduce a bird that the foxes had wiped off the island. That bird is here. It's a special brand ptarmigan that they captured back on this island on Attu, and they gave him a boat ride about 30 miles across the strait to Agatu, let him go, and now there's a few of these birds back on the island, and they hope they're going to repopulate the island. It's kind of a unique story because where else in Alaska could you sort of turn back the clock to reintroduce an animal that was there before people came, but then it was sort of extinct from the island, and now it's there again. All because there are no people there now. We have the opportunity to do this. Cold. Alaska doesn't have North America's record for cold. We missed it by 1 degree. We used to have it, Prospect Creek, up on the Hall Road. January 23rd, 1971, thermometer, an official thermometer there, dropped to minus 80. But it wasn't the lowest in North America, because in 1947, at this place called Snag here in the Yukon, the temperature dropped to minus 81 there. There was an old airstrip there that the Canadians abandoned in 1967. It was part of the Lend-Lease program. So this weatherman, Jim Brader, he was curious about Snag, so he went in there. I went with him a couple years ago. We skied into Snag. It's about 15 miles off away from Beaver Creek in the Yukon. We just skied out there. We camped out there. In January, we were tempting the winter gods to give us their worst. But it was pretty warm there. We're pretty happy about that. It was plus 5 or so. Anyway, there's Jim. He works here in Fairbanks at the forecasting office. And his mom liked this photo so much that she painted this picture of Jim. And Jim was there on a mission. He wanted to put up his own thermometer, minimum temperature thermometer there in Snag. So we found a really cold looking spot down by this old Indian village down by the White River, and put up this minimum temperature thermometer, which tells you the coldest temperature that's been there since you looked at it last. So we went there the next summer, because you can drive out there in summer, and it got to minus 63 F in Snag, when it had only gotten to minus 40 in Fairbanks. So Snag is a pretty cold place. We hope to someday put thermometers in the coldest places in Alaska that these weathermen think are the coldest places anyways, because these guys think that Alaska could knock off that minus 81 if we had official thermometers in better places. The only place we have official thermometers now are places where people live, but there are undoubtedly some colder places out there. In fact, this spring, in February, we had a cold snap. Chicken got to minus 72, the official thermometer there. So the all-time low for North America is minus 81 at Snag. That's only 9 degrees off. So these weathermen think that there's somewhere out there, if we could get the thermometers there, that could be colder than minus 81 in Alaska. Okay, we head way down to southeast Alaska. This is a place called Lituya Bay. It's sort of on the outer coast on the open Pacific. If you went further inland, you would hit Glacier Bay eventually. Lituya Bay is a lot smaller, but it's a very interesting place for reasons I'll tell you about here. This is a couple scientists who went out to Lituya Bay with really precise GPS receivers that tell them how much the Earth is rising or falling. It tells you elevation really precisely to the thickness of a dime. And they're interested in Lituya Bay to see how fast it's rising, because just like Glacier Bay, just 200 years ago, there was a lot of ice in Glacier Bay. It was full. It wasn't even a bay. Lituya Bay was the same way on the outer coast. It was full of ice, 10 stories high, and just an amazing load of ice there, and it's all gone today. So they're thinking, okay, all that ice was there 200 years ago, now it's gone. That much tremendous weight, it's bound to affect the foundation of the area. And it does, because the Earth's crust sort of floats on molten rock in the Earth's inner layers. And so when you take all the weight of that ice off, when it melts, the crust wants to come up. It's what they call glacial rebound, and it's happening really strongly here in southeast Alaska. Like, this area is rising like an inch a year. So that's what these guys are measuring out here. They want to find precisely how much it's rebounding out here. There's Lituya Bay in the right-hand corner of this picture. And it has a really interesting linear feature here. That Desolation Valley is a strike slip fault, just like the Denali Fault. So there's a lot of earthquakes in the back here. And here's the back of Lituya Bay. And in 1958, there was a really big earthquake, magnitude 8. It shook a big part of this mountain into the water, into the 1,000-foot deep water. Big chunk of a mountain goes in water. Water's got to go somewhere. The water went up this hillside. A giant wave hit this hillside. It sheared off all these trees. You can see the dark green trees on top. Those are the Sitka spruce, big, 4 feet in diameter trees that are just old growth there in southeast. But this wave in 1958 went up this high, sheared off all those trees, and just spit them out the mouth of the bay. Another unique place in Alaska scientists are really interested in is the Valley of 10,000 Smokes. This is the site of the biggest volcanic eruption in the 20th century. In 1912, there was a 3-day eruption there that turned this whole 40 square mile valley into, it was this really lush country, very green, very wet, Great Bear country, but it turned it into this moonscape. When Griggs visited in 1916, 4 years after the eruption, it was still smoking. There was still a lot of fissures, a lot of heat coming up from the valley floor. That's why they named it Valley of 10,000 Smokes. Now there's not so many fissures in the valley floor, and it doesn't smoke too much anymore. But there's still no vegetation there, 60 years later. And it's just an amazing place. This is John Eichelberger, scientist who now works in Washington, D.C. He used to work for the Alaska Volcano Observatory. He leads these incredible week-long trips into the valley every year, and he's doing it again this summer. But here he is at Katmai Caldera, the former site of Mount Katmai, which was a 6,000-foot mountain in early June 1912, but then 3 days later it was a 4,000-foot mountain, and the whole mountain sort of imploded into this crater. It didn't blow up, it kind of got sucked down into this mountain, and now there's a 300-foot walls down to this 600-foot lake. It's just one of the most amazing places in Alaska. Alright, I'll wrap it up here with some country you guys are familiar with, and I'm a little bit more familiar with now since a week ago permafrost scientist and adventurer Kenji Yoshikawa started a snow machine trip way down at the bottom here at the village of Imanik, and he went all the way up to Kotzebue, about 900 miles. Did it in about 2 weeks. We stopped in every school for the night. Some schools we went on by during the day, like Galvin. We didn't stay overnight in there. We stayed in, White Mountain. But yeah, we went through Imanik, Kotlik, we didn't stay there. Stebbins, stayed overnight there. St. Michael, Unalkleet, Shaktoolik, Koyuk, Elam, Galvin, White Mountain. We stayed in Nome a night. Teller, Brevig Mission, Wales, over to Shishmaref to Deering, and then Deering up to Kotzebue. Here's some fresh shots from that trip. This is Kenji on the right, Toru Saito, who lives here in Fairbanks, on the left. It's our sled load of stuff. We had 2 sleds for a while, and we had 3 machines and 2 sleds, and we probably met a lot of you guys on the trip. And in the DVD version of this, I have a lot of photos of your classrooms, so maybe you can see yourself in those photos. Anyway, here's Kenji. Kenji is a very unique person. He's done a major human-powered trip on every continent. Among them, he has walked across the Sahara. He skied to the South Pole, Antarctica. He tried to take a boat up the Amazon, but didn't quite make it. And when he came to Alaska, he sailed here in a boat that he made. He built the boat in Japan. It's a sailboat. And he sailed from Japan. He came up to Nome, and then he kind of refueled there, and then he sailed up to Barrow, and from Barrow, he just let his boat freeze in there. It froze in, all tilted and stuff, and he just stayed on the boat, because that's what the old explorers did, like Nansen did when the Fram froze in. They just stayed with the boat and just continued to eat whatever food they had left. Only Kenji would, people were curious about him, so they would snow machine out from Barrow to see him, and they'd bring him fresh food and stuff. And he did his dissertation out there. He wrote it when he was in this tilted boat. Just shimmed up his tables and stuff. Anyway, from in Barrow, he met his wife, who was a nurse there, and they got married, and he moved to Fairbanks, and now he's a scientist here, and he's traveled all over Alaska. He's hitting, seems like almost every village in the north, because he's really interested in permafrost. So he wanted to come on this trip because the scientists didn't know whether there's permafrost, say in Emonic or Kotlik, those farther south places at the Yukon Delta, because it floods there a lot too. And when places flood, the water puts a lot of heat into the soil. It just sucks a lot of cold out of the soil. So he was thinking maybe that might affect the permafrost. And he found out, yeah, maybe it did. In Emonic and Kotlik, he didn't find permafrost in the places he drilled. But he did find permafrost in a lot of other places, like Stebbins, St. Michael, Unalakleet, Tulik, Koyuk, Elam, and White Mountain. He didn't find permafrost because your villages are on such south-facing slopes, really nice sites that get a lot of sun. And he thinks maybe that's why he didn't find permafrost where he drilled. He did find it at Golovin, and he found it Teller, Brevig Mission, Wales, found really good permafrost, or bad, depending on your point of view, in Shishmaref, also in Deering and Kotzebue. There's Kenji, there is Kenji on the right, and Toru. Toru, he's the guy who works at the International Arctic Research Center, and he's also very helpful to Kenji. He really helps him when Kenji's doing his drilling and stuff. Anyway, here's some shots from around where you guys live in the Seward Peninsula. This is part of the graveyard in Brevig Mission. This is Shishmaref. There's Ken Stenik there, and Dave Atkinson. He's a scientist who studies storms and weather on the west coast of Alaska. This is that same shot down at the bottom in 2006. That's a house that had been abandoned. That was in 2004. Shot taken by weatherman John Lingus. And the shot in 2006 was taken after there was a big storm in fall of 2006 that eroded a little bit more of Shishmaref's coastline. And Shishmaref is a pretty interesting site. Noticed it in the summer when we were there, and even this time when we were there a couple weeks ago. When Kenji drilled, all he was bringing up was sand. All other villages have at least a little bit of organic soil. It's blacker, it's richer. But Shishmaref is just, all they were getting was sand and ice crystals. And when you look at a map of Shishmaref, you can tell it's on a barrier island, which it's unique among just about any place in Alaska I've been to. It's definitely the sandiest place. So as Ken will tell you out there, the villagers are kind of looking to move inland to a site on Tin Creek, which looks like a pretty nice site, but they're not sure if they're going to pull it off or not. They still have to raise a lot of money to match what the government's going to put in for the move. There's a shot of White Mountain. Here you can see maybe why a village like this doesn't have permafrost. This is the village is kind of facing toward us, and this is a south-facing slope where the sun has just hit that cleared area for years and years and years. And it's really sort of an extreme slope too. So the sun really is striking it hard right now. That's the old White Mountain School. Beautiful school right on the Fish River. Unfortunately burned down. You guys out there getting your new school hopefully this summer, right? But your new school was so nice. I mean, your old school was so nice. Here we are just jumping around the peninsula a little. This is on the northern coast of the peninsula. It's kind of right between Shishmaref and Wales. We were out there a week and a half ago and was pretty excited to see this polar bear track. I'd never seen a sign of a polar bear before. And we crossed one's track that was walking from the mainland. He just walked straight out onto the ice. This is the interior of the Seward Peninsula. Got some really neat mountains there. This is between Nome and Teller. There is Kenji, the unstoppable Kenji, who, when we were out there, he has this drill, and he drill holes. He tried to get them about 15 feet deep, just about the diameter of the bottom part of that drill, and then he would drop a string of thermometers there to get temperatures all along the way, to just see what soil is frozen. The top layer of soil is always frozen because the cold air freezes that. But sometimes when it's frozen down beneath that, that's permafrost. That's ground that's been frozen since about the last ice age. And that's what he's looking for, to see how much of that is left and how cold it is. And he found in his preliminary tests out there that some areas have really warm permafrost, like St. Michael was very close to 32. It was like 31.6 or something. So he thinks if the air temperature stays warmer, that St. Michael might change a lot. But some areas like Shishmaref have really cold permafrost, which is about, it's probably about like 29 degrees Fahrenheit. So, and ground is really stable, so it would take a lot of warm air over a lot of years to really make that thaw. And yeah, I said Kenji was unstoppable. This was in Shaktoolik. Shaktoolik, we rode in, and God, it was blowing like crazy. Jake showed us the weather station there on top of the roof of the school, and it was blowing a steady 30 miles an hour from the east. And those poor guys, it seemed like it had been blowing like that for a couple weeks. So they were getting a little tired of it, just like we do of the cold snaps here. When it gets to 40 below in Fairbanks for a week and a half, you get pretty tired of it too. Anyhow, so it's blowing 30 miles an hour. Ambient temperature is probably 0, so pretty good wind chill. But yeah, we rode in with Kenji. He talked to Jake's class and another teacher there too. I forget his name. Jesse. Yeah, Jake and Jesse's class. Talked to the class, and then bam, he went right out to drill, even though it was really blowing. In this picture, you see both him drilling and Toru's there in his park over there too, trying to get something else done. And yeah, Kenji would always work on these drill bits with his bare hands, even though it was really cold. And he would always, he had these things called frost tubes, which is these big plastic tubes that he left at just about all the schools in BSSD. And they have food coloring in them, and they're so the students can, in the fall, they'll be able to tell as the ground freezes. They will be able to pull out this tube, which goes underground, and see how far down it's frozen. So you guys will be able to track how far down the ground freezes and how fast it freezes. Anyhow, to make these tubes, he would take a blowtorch and he'd seal one end off, just kind of melt the plastic, and to pinch the end, he didn't do it with a tool or anything. He just did it with his fingers on molten plastic. The man feels no pain. There he is drilling in Stebbins with a sundog behind him, and the drilling was really tough there. There you see his drill bit. It was tough there because it was cold. It was probably about 10 below in Stebbins on that morning, and his equipment, it would be really hard to get his drill bits together and stuff. So the trip was a bit harder because it was kind of cold. But Kenji is unstoppable. There he is in Golovin with Jacob Copenhaver. Jason, sorry. Yeah, we stopped in there. That was a day that Kenji hit 3 villages. Yeah, we woke up in Elam, he talked to a class, then we snow machined over Little McKinley to Golovin. He drilled this frost tube. That's what a frost tube looks like. That's what he's snuffing out with his fingers there. And then he talked to the class, and then we drilled a permafrost observatory, which is a thicker diameter hole there, after he talked to the man in the back there, who told him a good place, and Kenji found, yeah, it was a great place. And then we went to White Mountain, which is about 17 miles away. We rode there. Then Kenji, we got there too late for their classes, so we didn't talk to a class that morning. But we drilled another hole there, another permafrost hole, and then he talked to the class the next morning before we left. So, non-stop action with Kenji. One great thing about traveling on this trip was we got all these great sunsets. You guys get such beautiful sunsets out there in springtime. And to close out the show here, here's a bunch of sunsets. Here's one from Stebbins with a raven flying over. St. Michael, the graveyard there. This is Unal Cleat. He was getting a sea ice sample for Hyoiken, another scientist here at UAF. That is the moonset the next morning from Unal Cleat over the sea ice. That's Shaktoolik. We were using the back of the school as a windbreak. It's a little fuzzy because it's blowing like crazy behind the school. And Koyak. And this is a spring photo from the beautiful Fish River in White Mountain. And this is one of our favorite places on this trip was Wales. That's looking out to Fairplay Rock. And this is Breivik Mission. There's some moose antlers and a few seals. And there is Shishmaref, and this is from last spring. So that is the end of my mentor talk, and I'll take some questions.
First off, we'll go to Kenji's and your trip, where you said that there was no permafrost. Did he still put in the stations or the test sites?
Yeah, that's how he found out there was no permafrost. He drilled first, and then when he got down, like in Amonik, he found this really black, gooey soil way down that wasn't frozen.
So he'd leave it there, just test temperatures, or he wouldn't leave a final one?
Yeah, he did leave a regular station there with thermometers in it and everything, so you can check it later.
In other sites where you've gone with scientists, like the temperature, who do they go to get the calibration to have an official temperature so that the Weather Service can use it?
You usually have to coordinate that with the National Weather Service. They have certain standards, and they have instruments they want you to use if it's going to be an official site.
Now on that spot, does he have to go back to read the temperature, or is there remote communication or information being sent back to equipment?
Yeah, it kind of varies on the site. Some sites are so hard to get to, like the top of Mount McKinley, that they just have data loggers there that people can go and download every year or whatever. That one had some satellite and radio telemetry that would give the information back to us at UAF, but that sort of broke up there, so they had a backup of a data logger. And the data logger is kind of the fail-safe. It's something you can leave there and then go download it. It's not as complicated. But a lot of sites that are sort of remote, but where they have a lot of funds to put a lot of infrastructure in there, they'll have those hooked up to satellites or to other sort of ground transmit stations where they can get telemetry and get like real-time information.
In the case where you have the scientists who they took out the foxes and put the birds who were natural to that environment back in, are they monitoring it? And if so, how long do they monitor if there's nothing there that would be a predator to the birds they're introducing?
They monitor it until the birds are sort of doing well enough that they think they don't have to anymore. Like there was a bird out there they thought was extinct. It was called the Aleutian Canada goose, the Aleutians. And but then one scientist found a bunch of them on one island, one real remote island, And so they, when they started removing foxes from other islands, they reintroduced this goose to those islands. And after about 20 years of that work, the geese were just coming back in such great numbers. You know, they're seeing hundreds of nests on every island that they stop counting them every year, and they'll just sort of monitor them. If they notice they're not seeing a lot of geese, they might start monitoring them again. But right now, they're not doing a formal count.
On some of these trips you've taken with the scientists, it seems like because their remoteness, other scientists attach onto that. Is that common practice? Or does it have to be written into their research?
You mean decide to share like logistical?
Right, or if there's going to be a scientist out, a remote scientist, maybe another scientist, while you're there, can you help? Is that common? Is they help each other that way?
Yeah, it is, because a lot of these places are pretty hard to get to, so one scientist will help another, like on Denali, for example. The scientists who were working on the weather station brought up another experiment, this one for Kenji Yoshikawa again, just a temperature gauge that he wanted to just leave up there on a rock, attached to a rock.
Now, as you as a writer, a science writer, going into these trips, how much research do you have to do, or how much do you work with the researcher to know what you're getting into?
A lot of them I've interviewed beforehand, so I sort of have a background on what they're doing. So that helps a lot. And if I haven't been with them before, it helps just to read their papers they've written on the subject, or whatever else they've written. A lot of them have websites now, and there's a lot of good information out there where you can get up to speed pretty quick.
With this in mind, what was your favorite trip with the scientists, and why was that your favorite?
The one to the Western Aleutians was a favorite because it's just an area that's really hard to get to. It's a national wildlife refuge. There's no villages out there or towns, so there's no flights to way out west in the Aleutians. You pretty much have to be on the boat to make it out there. So just a rare opportunity, and really neat country where people have lived for years and years. Just really, really remote feeling. Place where you feel like you probably won't get there again.
How did you get into your field of work?
Oh, I always sort of admired the writing of Carla Helfrich, who was a science writer at the Geophysical Institute in the early 90s and late 80s. Always liked her columns. And then one year I'd just gotten done with the summer working as a park ranger out on the Yukon River, and I saw that her job had come up. It was advertised in the newspaper, so I applied for it and I got it.
What schooling does it entail to get you ready for this? I mean, if there's a student out in Bering Straits, what would you tell them?
I would tell them to get experience writing and working with good editors, and to be interested in a lot of different subjects. Like for a science writer, like my job, I have to write about usually something different every week. So it helps to just be interested in a whole lot of different things, like biology, like ptarmigan, volcanoes, the aurora, just about anything you could think of related to science. For me it was good to have a journalism background, because that's probably the harder part, is to be able to write things fast and turn them around.
In your career here at the university, has there been a research project that you followed from the beginning to the end, and if so, was there something exciting about watching the results that come in?
There's there's one that UAF scientists did in the early 90s, and they sort of came to a good point about 2000 where they were studying glaciers. Keith Eckelmeyer was flying over glaciers in his small plane, and in the belly of a plane he had a laser rangefinder that would tell him the precise elevation of this glacier. And he flew over all these glaciers in Alaska, and he could tell just how high the ice surface was. And they compared those to the USGS maps, which were drawn in the 50s, and they found that there was quite a rate of ice loss from the 50s to the 90s when he flew them. There was a great elevation loss, which told him that, wow, all this ice melted from the 50s to the 90s. And it was sort of one of those wow things where they found all that information out at once when they went back to those old maps. I had a graduate student doing that. So that was sort of a big jump where a lot of work came together at once and showed this massive change in the landscape of Alaska.
When working with these scientists and going out in the field, do you have advance notice, or are there times when you have to leave right now, like as in the earthquake that we had?
Yeah, stuff like earthquakes are pretty spontaneous, and volcanic eruptions are like that too. I mean, they happen now, and scientists get right on them and get right out there. Most of them, though, the scientists do their field work in the summer, so they know the winter before what they want to do, and they have it all planned out, so you can get with them at slow times like in January when they're just sort of formulating what they're going to do, and try to hook up with them there for their field work. But then a lot of them do their field work in winter too. Like Kenji does a lot in winter, a lot of permafrost stuff. So he does some of his planning like year round.
Have you seen an increase in activity since you first started?
There's always been a lot, it seems like. International Polar Year has upped it a little bit, but it seems like there's a lot of scientists in Alaska doing a lot of interesting things. And there's a lot of scientists from outside Alaska doing a lot of work in Alaska. There's this one conference the Geophysical Institute sends me to in December in San Francisco. It's called the American Geophysical Union Conference. And you just search the list of talks there, and the word Alaska comes up hundreds of times. So there's a lot of scientists here studying it. There's a lot of scientists outside studying it also. And yeah, probably recently there's been more interest, like in the last 5 years. But there's always been a lot since I've started looking at it, since the 90s.
Now, I know that our scientists come into the state to study, and our scientists also study outside in different countries. Are you able to follow along with any of those?
Yeah. For example, these permafrost scientists are going everywhere they think there's permafrost. Vlad Romanovsky goes to Russia a lot. That's where he grew up. Siberia is fairly similar to Alaska, just in that it's way far north, and there's a lot of permafrost there. So, yeah, I follow what he does over there, and a lot of sea ice scientists have Russian colleagues, and a lot of people who study ice at the top of the world. They start out in Russia too and do their cruises to see what sea ice is there and what's not.
Now, the trip you just took with Dr. Kenji, he works with students and they'll help with the information. Are there other scientific research that you're familiar with that have students help?
Yeah, there was one where this atmospheric scientist wants to sample snow, and he wants teachers to help him collect snow. Mark Jeffries does his lake ice snow surveys with students kind of all over Alaska, and trying to get some help bearing straight with the weather observing also with the weather stations.
So the scientists that you have seen or worked with, is there a standardized procedure that is it important to have standardized procedures in order to have the results helpful for the researchers?
Yeah, and that's a major goal of this International Polar Year, sort of to get everybody using the same instruments, if they're doing the same type of measurements, like for permafrost or whatever, to use the same type setup. That's why everybody wants officially sanctioned thermometers, and they want skilled people putting them in so they don't put them by heating vents or other things that can skew the results. Yeah, so the quality of data is very important, because that's what they ultimately base their judgments on, from what the data tells them.
Do you have a blog site or an email that if people are interested they can contact you and you can refer them to scientists or for the information that will be helpful?
Sure, probably the most useful one is to go to the Geophysical Institute's website and go to the Science Forum. That's the column that somebody from the Geophysical Institute has written since 1976, a weekly column, so there's a couple thousand of them on there. Just a lot of Alaska topics on there. And my email is at the end of every column I've written, so there's a lot of columns there with information on them.
Now I know you write the science column for our Geophysical Institute and you write for the Fairbanks News Monitor. Has this led you to other publications? Have you published writings elsewhere?
Yeah, I also write a monthly column for Alaska Magazine. It's on natural history now. It used to be on Outdoor Adventure, but I write it every month for them, and I write some features for them. Also, I also have a blog that I write on. I wrote a lot on it. It's called AlaskaTracks.com. I wrote a lot during the recent trip on the Seward Peninsula, and that's sort of a natural history based blog too.
Thank you, Ned Roselle, for a very helpful, informative talk, and we hope that some students get some ideas from your talk on how they can continue their interest in science or other ways to get into science like writing. And we'll see you later. Thank you.
Thank you.